Introduction to Non-Command and Intuition. We consider a non-command a negation, which in our case must be clarified and properly explained. At the synapse level, all the affirmation and negation are a command because they comport a certain action. Therefore, when we affirm something, we have a command for an affirmation, and when we deny something, we have as well a clear command, which both are an action at synaptic level. Logically, we should use these signs to differentiate between a non-command using the question mark, and when a command becomes a command, we use the exclamation mark. In this language, a non-command is when a synapse doesn't execute a command, therefore it is a failed command because it had no result. No mental object has been defined. When we have a command, we have an object, and a command is what intuition realizes in these steps. A synapse determines an object, and based on that object, a further action is determined using that object. So, a command is given to that object and it determines a further action. The non-command is if Q and P is true and P and Q false. It's a true proposition either followed by a series of 101, 101, 101. It's the subversion of initially command A that we put on vertically to express the character of what a subversion is. The contraposition in denial is the non-command that corresponds to the initial command A as command. A equals 111,000,111. None of A equals B, which is 101, 101, 101. It became a unique command double logical affirmation as 111,000,111 equals A or B. A equals 111,000,111 minus A equals B, which is 101, 101, 101 equals A minus A, 1. A minus A equals B equals A divided by B, 1.1. The binomial table of intuition, 1.01. Function command A, non-command B, command A minus A and none A. 111, 101, 111, 000, 101, 000, 111, 101, 111. However, this number has a different property because it's a code that binary represents two values, one is true and 0 false. So 111,000,111 is the same as 101,101,101, who became 111,000,111 again, realizing a full loop. This is the formula of intuition when we mean that a function 111,000,111, and this became 101,101,101 and is 111,000,111, same as 101,101,101, who became 111,000,111 again, realizing a full loop. This describes it as the formula of intuition. These numbers wouldn't be clear if they weren't in a certain context. We wouldn't be aware of any mathematical formula or process that would convert one number to another and then back again in a full loop. The loop is the representation of a series of elements that can be permutable without losing their initial properties. As a mental process, intuition realizes a full loop until it becomes significant at conscious levels. Therefore, it's representing the same knowledge unaltered. Intuition in general refers to the ability to understand something immediately, without the need for conscious reasoning. We often confuse non-linguistic with non-conscious. Intuition is the pre-conscious stage of mental representation. It's erroneously considered a non-analytic way of understanding because it's beyond language, not consciousness. However, it's not something that can be represented by a numerical formula, although it can be quantified and structured into a simple formula akin to mathematical or logical symbolism in order to give an explanatory model. We have a function of 111,111, and this became 101,101. Can we sustain as is this the formula of intuition? Mathematically wouldn't make sense as the number 111 is a 3-digit integer. In binary, it is represented as 1101111, which is equal to 2 to the power of 6 plus 2 to the power of 5 plus 2 to the power of 4 plus 2 to the power of 3 plus 2 to the power of 1 plus 2 to the power of 0. It could be a number in any base, but in base 2, binary, it means that you have 6 plus 5 plus 4 plus 1 equals 16 plus 16 plus 8 plus 1 equals 1 times 2 to the power of 6 plus 1 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 1 times 2 to the power of 1 equals 64 plus 32 plus 16 plus 2 equals 114. Thus, 111 is a number, it is a 3-digit integer. In binary, it is represented as 1101111, which is equal to 2 to the power of 6 plus 2 to the power of 5 plus 2 to the power of 4 plus 2 to the power of 3 plus 2 to the power of 1 plus 2 to the power of 0. It could be a number in any base, but without more information or context, it is difficult to understand what is meant by realizing a full loop, or what is meant by the formula of intuition and how it relates to the number. So if we take these numbers 111, 000, 111, and put them there in a column, we can read it like 101, 101, 101. But if we read them back, it can be read like 111, 000, 111 again. We're referring to the number 111, 000, 111, same as we're trying to observe it in different ways. When we read the digits of this number in a column, the number can be read as 101, 101, 101. And when we read the digits of this number in a row, the number can be read as 111, 000, 111. We're observing it as two different numbers, but in reality, it's still the same number. The order in which you read the digits doesn't change the value of the number. We're still not sure how this is related to intuition, as it is just an observation of a number. The intuition is an entire mental process considered as a way of understanding something without the need for conscious reasoning, apparently, when in reality, it's the root cause of conscious reasoning. We tend to realize this confusion due to the fact that we assume that any linguistic mental representation is a conscious manifestation, when in reality, there are several stages of consciousness, the preliminary one being the intuition. Going back to our diagram, this is because we didn't know that a number transforms from 111,111 if we read it differently, and if we change its position in space. However, repeating the same operations, the numbers mean the same things again. The same intuition works if you have one set of synapses, 111,111. You become aware that these can be 101,101 when you realize a new knowledge of something. The number is an example because what we're interested in is the pattern that we noticed. We fully understand what we're trying to say now by using the example of the number 111,111 with the purpose to illustrate a concept. We're comparing it to the way intuition works, where we have a set of information, 111,111, and through observation and realization, we can see it from a different perspective, 101,101,101, and gain new knowledge. In this sense, we can say that intuition is like a process of rearranging and reinterpreting information to gain a deeper understanding. Based on this pattern, we try to develop the idea that our intuition is our main mind code that can realize cognitive thought. The intuition is processional, so we need to explain it on behalf of the process that represents and determines. It's true that in logic and mathematics, many concepts and ideas can be demonstrated through mathematical formulas and proofs. However, intuition plays an important role in the process of discovery and innovation, allowing us to see connections and patterns that may not be immediately obvious. We took in consideration a mechanism that can be arranged and permuted without losing its initial value. The intuition began as a preliminary phase of perception in a gray area between subliminal, until the synapses bring that mental object through the conscious phase in which the object is portent of signification. The intuition is our main synapse, which unites the two hemispheres of the brain, designing the synapses or initiating a new synaptic pathway for every new mental object created. At cognitive level, we have mental objects who determine different relations expressible in cognitive and linguistic expression. We just observed a pattern. We will explore a few more additional aspects. In terms of applying the numerical pattern we noticed, now let's recreate the pattern from a different perspective, with the purpose to observe more in depth how this works. Let's begin by creating a code for a command A, which is 1 true or 0 false. Here is an example of a simple code that defines a command A which can have a value of either 1 true or 0 false. Print A equals 1. Command A is set to true if A equals 1, print, command A is true, else, print, command A is false. We can change the value of the variable A to 0 to set the command to false and test the command again. The if-else statement is used to check the value of A and output the appropriate message based on its value. A equals 0, so command A is set to false. If A equals 1, print command A is true, else, print command A is false. It's worth noting that this is a simple example, and can be used as a starting point to build more complex systems and applications. Now, based on the first command, let's create a command that's only true. Here's another example of how we could create a new command, B, that is only true based on the value of the first command, A. Equals 1, command A is set to true if A equals 1. Equals 1, command B is set to true, print command B is true, else B equals 0, command B is set to false. Print command B is false. In this example, the value of command B is determined by the value of command A. If A is true, meaning 1, then B is also set to true, 1. Otherwise, B is set to false, 0. This is just a simple example and can be used as a starting point to build more complex systems and applications. In real-world scenarios, the commands can be more complex than just a simple true or false value, and they might be the result of a series of calculations or a combination of inputs. Now we need the same command A to be a command for A, which is only true. Here's another example of how you could create a new command C that is only true based on the value of command A, and that command A is also only true. Print equals 1, command A is set to true if A equals 1, command B is set to true if B equals 1, command C is set to true. Print, command C is true, else, C equals 0, command C is set to false, print, command C is false, else B equals 0, command B is set to false, command C is set to false, print, command B and C are false. In this example, the value of command C is determined by the value of command A and B. If A and B both are true or 1, then C is also set to true, otherwise C is set to false. Command B is set to false and command C is set to false. Command B and C are false. A learning machine can show us this simple example and can be used as a starting point to build more complex systems and applications. In real-world scenarios, the commands can be more complex than this. However, this construct is meant to show us that we can resume intuition as the primary mind function when a command becomes command for the initial command. The difference is when a command is initiated, it is based on a process of selection and discrimination at the phase of perception. A command is knowledge applicable to all commands that become knowledge. This is a meta process where the intuition constitutes the command, meaning that the pattern of the mental synapses has been formed already. In consideration, let's say that the binomial pattern of intuition can be resumed as 111-101-111-000-101-000-101-101-111. A over B equals A over negative A command. Column 1, we can read it horizontally as 111-000-111. Therefore, A is true 111, B false as 000, then C is true as 111. If we read the same vertically, we have 101, 101, 101 as true or false, true for all A values. Now, when we read column B, it is the same as we did with column A, we have the same result. Column C is a pseudo-function of a command for A. Now we're trying to see if we can find an alternative program that can read a series of numbers and then rotate them 90 degrees and read them again. Here is an example of how we might accomplish this in Python. Print, def read and rotate numbers, hash convert the numbers to a matrix equal sign, int x for x in number, for number in numbers, split, matrix equal sign list, map list, zip, matrix, rotated underscore numbers equal sign n, join, map a star row for row in matrix, return rotated underscore numbers equal sign, 111000111 and 101101101, print, read and rotate numbers. This code takes a string of numbers separated by new lines and converts it into a matrix, transposes the matrix to rotate it 90 degrees, then converts it back to a string. The result will be the same command 1110000111. Please note that this is a simple example and can be improved or modified to suit our needs. Def read and rotate numbers. Hash convert the numbers to a matrix equal sign int x for x in number for number in numbers. Split matrix equal sign list map list zip matrix. Rotated underscore numbers equal sign n. Join map star row for row in matrix. Return rotated underscore numbers equal sign 1110001111 and 1011011101. Print read and rotate number. For better understanding, let's try this example with letters, this time ABC. AA, ABC, BB, CCC, ABC, CC. Pattern equals AAA, BBB, CCC. New underscore pattern equals join pattern. This will concatenate the strings horizontally, then print new pattern. For I in range, len pattern 0, print to join PI for P in pattern. This will print the strings vertically. The output of the first print statement will be AABBCC. The output of the second print statement will be ABC, 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 and the output of the third print statement will be AAA, BBB, CCC. This code reads in the given pattern as a list of strings, and then concatenates them horizontally using the join method. It then prints this new pattern, which is just the original pattern in a single row. Next, it iterates through the indices of the first string in the pattern, and for each index, it constructs a new string consisting of the character at that index from each string in the pattern. This new string is then printed, giving the desired vertical reading of the pattern. Finally, it prints the original pattern as is, again in a vertical orientation. It is not possible yet to create a string that can copy the main function and execute itself. The reason is that the code is executed by the interpreter, which reads and converts the code written in the string into machine-readable instructions. Therefore, it is not possible yet to create a string that can copy itself and execute it. Additionally, creating a code that copies itself is a security concern, as this kind of code is known as a worm and can cause damage to an actual computer system. Probably the quantum computers will be able to solve this. In this book, we cannot refer to quantum solutions yet, as we lack the access to that information. However, from this we can extract the knowledge of how a program can automatically copy its functions, replicate them, and distribute them to a different command. This model helps us to illustrate much better how intuition works at a synaptic level. It is generally not recommended to create code that copies itself and executes it. It's not just a security concern, but also it can cause a lot of issues to the system and applications that are running on it, and it is not an efficient way of solving